And I didn't realize before how much common I have with the previous talk. You know about asteroids, you know there are surveys, and one of the newest instrument which is looking for asteroids we haven't known yet is the repurposed WISE. Asteroids are hotter than the objects they are looking for because of the sun. But anyway, so that's one thing. And also Jeff said that we will protect you somehow. Let me tell you that I might be one of those people. I'm heading out tomorrow to the observatory to actually go and find some of these things. Okay, so what about this death by asteroid? Why do we even worry about it? And now I need somebody's help because I just lost my... So, a couple of weeks ago, maybe about a week ago, you have seen that, oh, there's a report that a guy in India has been killed by a meteorite. Oh my goodness, is that really true? Well, it turned out not quite. There was a natural explosion, but from history we know that there are actually cases when people are killed. The only documented case happened more than 100 years ago. It was way out in Siberia where there aren't many people, so you know they were really unlucky. It also killed a couple of reindeer. And if you think about it, there's another guy. There's this, I'm sorry, that was a lady. In Alabama, she actually got hit by a meteorite. I do not have a picture, but if you look on Wikipedia, you can actually find a picture of this lady with a humongous bruise. And she really was hit by this thing. And then there are some other things. There is a boy hit on the head, but luckily he wasn't hurt. And there are other things like, you know, somebody's driving by a car. Now think about how unlucky he was, that he just happened to be right there when this piece of rock, space rock, came through the windshield and hit him. And then there is this thing, notice the date, almost exactly 2 years ago. No, that's 3. 3 years ago happened in Chelyabinsk. Something came down which injured people. Not by hitting them, no, but because of the shock wave it created. It also broke a lot of glass, and people were out there looking what the heck is going on, and they got hurt. So, of course, there are rumors, not necessarily confirmed, that there were cattle hit by car, dog was hit by a cattle hit by meteorite, dog hit by a meteorite, horses. It's possible. How do we know that that poor guy was not actually killed by meteorite? I have not seen the actual data, but what I can tell you that when a meteorite hits something, it's a foreign material. It is coming from space. It does look like, to an untrained eye, like a space rock, but if you do careful analysis, then you actually realize that it doesn't match any Earth rocks. So they were looking for this material. They were looking for something called shocked quartz. Well, didn't find that. You also look for sand, because it doesn't matter how small it is, you still get this heating and you can get a little bit of glassy material in the surrounding. They did not find that. Of course, another thing is they actually did see a crater. Maybe that was the first, what gave them the idea. And if you look on solid surfaces in our solar system, there are craters everywhere. There is Mercury. The middle picture is Mars orbiter. Mars observer was actually looking at a region, and below it there's another region. There is the same region a little bit later. Something really did hit that poor thing. And then you can see it on other moons. You can see it on the surface of comets. You can see it on our asteroids. So if it has a solid surface, it has impact craters. Of course, we also have exceptions of Jupiter's moon Io, which is very, very volcanic. And as soon as you put the craters on it, it gets resurfaced because of the volcanic activity. So we do know that cratering happens, things get hit. On Earth, it's much harder to see because of the continental drift. Actually, this continental motion recycles the surface of the Earth, but in spite of that, we actually found about 184 of these confirmed meteorite impact, and the way you do it is you're looking for foreign material, you look for overturned surfaces, you look for shocked quartz, you look for glass bubbles, glass particles flying out. Basically, you are melting sand, and you know that molten sand is basically glass. So you're looking for those. You don't have to remember that. There will not be a quiz, but if you look at it, there are quite a few ones. which are old. There is one that, I don't know how to pronounce it, is up there in the north. There is one in South Africa, that's the Rutherford, and those are 2 billion years old. Think about it. Almost half the age of the Earth. And then there are the largest one. One is, again, this Rutherford. The other is the famous crater in Yucatan. Now, if you think about it, the largest craters are usually also the oldest ones. If you do the statistics, you realize that it looks like that, yeah, in the past, and you can do it for the moon, you can do it for Mars, you could do it for other solid surface, you realize that there was a time in the past, about 2 to 3 billion years ago, when you get a lot of big impacts, but since then, it tapered off. Well, it's kind of nice, and I'll tell you why. Well, it means that we are not going to head with a really, really, really big asteroid. The one which killed the dinosaurs, and I checked, honestly, I went through that picture. It says that there is the Dinosaur Killer asteroid on this to scale. Okay, I looked at it. I'm not asking you to do it because you won't. So what I did, I actually looked and found that really teeny tiny speck at the end of that arrow, maybe 1 or 2 pixels. So that was the sign of the size of the dinosaur-killing asteroid, and there's the whole Earth. So when you are seeing these wonderful little animations or pictures, this is what you see. That is a rock which is actually not comparable, but you can see it compared to the Earth. But that's not right. The Dinosaur Killer was about a 10 to 15 kilometer asteroid, and in size that it's really, really just a tiny speck compared to the Earth. But it could do a lot of damage. Why? Well, it hit the Earth. If you were there, you're toast. Of course, when you are hitting the Earth, you are forming a crater. In a process, you throw up lots of material, from boulders to microscopic sizes. So you get these boulders coming down, creating fires. There goes your food. And then the tiny microscopic parts go up in the atmosphere, and if you put a lot of it, it could actually block out the sun. So again, there goes your food for the next 10, 20, whatever, 100 years. Whether the dinosaurs were really killed or they were just unlucky that it happened to come around the tide doesn't matter. We know that something in 10 kilometer size, if it hits the Earth, we are toast. And I have to tell you, if it's 10 kilometers, there isn't much we can do. However, asteroids have a size distribution. Large asteroids like Ceres, Vesta, Pallas, these are above 100 kilometers, maybe 100 miles. The largest one is less than 1,000 miles. They have very nice stable orbits. They are hard to move because if they are big, they have a large mass. So these are going merrily around the sun in between us and Jupiter. However, you can have smaller ones. And we know that these smaller ones actually can hit objects. Okay, in case of Jupiter, it was not an asteroid, it was a comet, but it wasn't a spectacularly big comet, and it still made a black eye on Jupiter. And since then, with modern cameras, amateurs looking at Jupiter, and they can actually see impact. They see features which could be best interpreted as impact. And then, of course, again, we didn't see the actual collision. But we already know at least 2 examples, one found by Hubble. One was just somebody looking at that asteroid, realized at first they thought a comet because, it has something which kind of goes back like the comet has a tail. But if you look close by, like the inset on the right, it doesn't look like any comet. And modeling the dynamics of collisions, strength of these asteroids, and of course the whole solar system, it looks like our best explanation is something collided there. Now, the other one, Sheila, it's one of the bigger asteroids in the main belt, again, going happily around the sun between actually Mars and Jupiter, so it's not going to come. That was a big one hit by a smaller body and put out a lot of dust. And then, of course, the ones we are interested in, the collisions happening with Earth. Interesting thing is that one down here which says it was in Sudan, we actually knew about it. Didn't have long warning, we had about 2.5 days, but we knew where it's going to hit. And lo and behold, people were actually looking, and pilots were reporting it, and they actually saw the trail of something, but you see a fireball. And then there is the thing in Chelyabinsk, which got everybody by surprise. That was a thing which we didn't know about. Now remember, the Dinosaur Killer was 10 kilometers. The one down here is about a Volkswagen bug, the one which hit Sudan. And we confirmed it because we knew where it hit. So people actually could go there, collect the stuff, and get a good estimate of its mass. And then there is Chelyabinsk. Again, we knew where it hit. We collected a lot of the material. And it turned out that was about 15 meters, which is what, 45 to 60 feet in size. Human scale, it's big. But as far as asteroids go, this is really a tiny speck. Okay, so we have big asteroids happily moving around, and we have a bunch of asteroids which could come close to Earth, and that's what we call the near-Earth asteroids, and that's what I'm going to go and observe tomorrow. These are the asteroids which have a chance to come close to Earth, and if they have a chance to come close to Earth, they actually could hit the Earth. So, back to why was it good that the Dinosaur Killer was 10 kilometers. Here you see probably all the pictures we have of asteroids so far. Now, actually, I'm cheating. I didn't put Ceres on it. Since I made that slide, we actually visited Ceres, and we have better pictures. But as it turns out, it's more like Pluto. Well, something like that. It's rather similar to Pluto than all the other asteroids. So it's probably an interloper. Anyway, Vesta. And then some other things in size. You see they come in every kind of sizes, every kind of shapes. Why? We think when the solar system formed, which Dr. Coultool was talking about, that if you have a star and you have a ring around it and they like each other very much, they can make little planets. But there is a region where the tug between the star and the biggest bully in the family kind of have a tug of war, and you cannot really form big planets. But they are going around there, and as they are going around there, they can collide, and when you collide, you break it up. That's how it happens. If you have bigger bodies and you collide them, you end up with a rubble, smaller bodies. So, and if you have a breakup, that kind of explains the irregular shape of the asteroids. So, our saving grace is that you started with a lot of bodies, and then you had collisions, and then you can break it down, which means that you actually making smaller and smaller bodies. So you will have lots more of small bodies than large ones. Dinosaur killers do not come very often. Maybe they come about 80 to 100 million years if you do some statistical work. Now, some people says, well, and then we are due for another 10-kilometer one, but 10-kilometer ones are big. They reflect a lot of sunlight, so you actually have a good chance to see them. And we searched and searched, and we did not find any 10 kilometers one, which is, there is still a chance that something is hiding, but very, 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 very little. Okay? I'm just covering my bets because I cannot say for 100%, but it's a very, very small chance. So, I have to kind of talk about this vocabulary because we talk about meteoroids, we talk about meteors, and we also talk about, and I think it's missing a word, because meteorites are the small asteroids that basically have the Earth in crosshair. They disintegrate and burn up in the atmosphere if they are small enough, and that's what, oh no, it's there. You call them meteors. And if they survive, if they're big enough for some of the parts surprised and you actually find them, those are the ones you call meteorites. Just for fun, here is a part of that Chelyabinsk meteorite, and this is the crater it made in a lake, which made it hard to recover, but they actually did it, analyzed it, and it's actually a nice common chondrite. So, what are the odds? Well, as I keep saying, large asteroids are much less common than smaller ones. I looked up the statistics on something called NEOs, or near-Earth asteroids we have to worry about. We only know about 2,000 of them. There's many, many more. But only a few kilometers are above only a few of them are above 10 kilometers. And we are pretty sure we got them all. And the nice thing, again, they are much harder by non-gravitational forces, which are important on smaller ones, to move them from their orbit. So we can say they're going to stay there for a long, long time. In your lifetime, don't worry about it. How long mankind will survive, I don't know, but probably we need to worry about it as humankind, about the effect. So, a couple of statistics. As of today, we know 880 kilometer-sized asteroids, kilometer or larger, asteroids which could come close to Earth and they might actually collide with us. Now, however, we found most of them. There are statistics and them lied. Is that the correct quote? Well, we really did the statistics and it really does look like we did a good job on finding those. And we would be worried about them because, if they really hit the Earth, Dinosaur Killer, you kill whatever is around you. You have secondary fires that put a lot of soot in it, and then you put already a lot of dust. So you could probably threaten civilization or actually have people fighting over food, which could be unpleasant. Okay. So, what we are worried about, and that's one thing I didn't tell you, we are actually being bombarded right now from stuff from space. Most of them are really teeny tiny. Some of them are the size like the basketball. We are getting hit by a basketball every month. It's hitting the Earth. But we are living at the bottom of the atmosphere. So the atmosphere, because of the friction, it basically can squash it, it breaks apart, and the little pieces are either burned up, or if it makes it down, they already kind of settle down. They are coming down like a poor guy without its parachute, but you know that it's not really that big of an energy. It reaches something called terminal velocity. So, now, so we found the big ones. Little ones, we don't concerned about because it breaks up or burns up in the atmosphere. We worry about the ones which are between 100 and 300 meters because those actually have a chance to do some damage. Like the one in Chelyabinsk. That was a little bit smaller, so it didn't quite make it down to the ground. But if you are in 100-meter range, which is 3 football field, then that body actually have a chance to reach the ground and hit it. Okay. Either the ground, or it can hit the ocean, and you have tsunami. In either case, people on the coast or people on the continent are toast. But the nice thing is that this is in the size range where we actually be able to do something about it. And I'll get back to that. Now, when you are looking at the website, they say, oh, this asteroid has 1 in some chance to actually hit the Earth. Now, for the next 100 years, the largest one I could find which has a chance to hit the Earth, that's about 0.5 kilometer. Remember, that's much bigger than the one which we already thought that, well, maybe do something about it. But it doesn't matter because the chance that it hits the Earth, I don't even know how to read that, whatever, very small, less than 1 in a million chance, or the way I like to look at it, it has a 99.9999% chance of missing the Earth. I think that's reassuring. Now, the highest probability in that in that time range I could find was something called by that phone number. It's only 7 meters. We were lucky to find it because it had to be really close. But if it's 7 meters, it gets burned up in the atmosphere. So it has a much higher chance, 1 in 15, but it doesn't matter because it gets burned up in the atmosphere. Now, if it comes this high velocity, since we know about it, what you can tell people, okay, when you see this big flash of light, you duck and don't go to the glass because if it breaks, you get injured. That's something. Now, let me skip over that. But so how do you figure out this odd? How did I get 1 in 15 for that body, or how did I get 1 in 1 million for the other body? When you are observing something, only thing you can tell is it's in that direction, and you are not even that precise. You have an error on that direction, which means because you only have direction, the body could be here and small, could be a little further, but being bigger. and it could be even bigger if it's really far away. Now, it's not just not one astronomer who is looking at it, but more, so you can actually figure out where it is in space. However, you still have an error bar. All those things where it could be a possible point for an orbit. So what you're going to do, if you do that kind of thing, and you need amazing computing power, but you basically propagate, figure out ahead of time where does that orbit takes you. If that orbit takes you within the radius of the Earth, that means that is a distance which is smaller than the distance between the surface of the Earth and the center of the Earth, you're going to get hit. Now, so you can find out what are the orbits which are within, which lead you to actual collision with the Earth, and what are the other possible orbits, which gives you a safe distance. This is an example of that asteroid up there, 2013 TX68. I just realized Texas. Okay, so if you take all the orbits into account, on that day, this would be the possible positions where you have an orbit. When you have a point, the orbit would go through if you are looking from the plane of the Earth. And then you see that there is quite a few out here, but there are quite a few close to Earth. However, although the measurements have errors, we know, and integration have errors, we know that this is still a safe distance. But you can imagine that there are some asteroids where some of those points would be within the Earth body, which leads to collisions. So how big of a portion of these orbits leads to collision, that will tell you the probability of your collisions. So that's all I can say. Don't panic. You have a much better chance to kill by and why you shouldn't panic. Let's go back to the first side. Can you get killed by a meteorite? You could, but you still have a better chance to kill by an asteroid than being hit by the meteorite. And I can tell you that none of the known asteroids will collide with the Earth for the next 50 years. Now, again, here's the caveat. None of the known ones. But there are still many out of there. But what I would like to add here is that you actually have some ways to actually deflect them. And that's where this 100 to 300 meter range, which could do enough damage, but we actually could deflect them, is really important. We want to find those, and that's what my grant is for, to go and help find those things, because actually, even with today's technology, we have methods to kind of move them. You don't necessarily want to blow them to smithereens, because then you just, instead of one big bunch, you get a lot of them arriving at the same time. You want to nudge it. And how can you do that? There are ways to do it. You can send out a spacecraft. You know that gravity happens between any two bodies, you and me, everybody. We are all attract each other. So if you put that spacecraft up there, it will attract the asteroids. The asteroid will attract the spacecraft. So if you keep it in a specified distance from the asteroid by burning its engines, letting its engines run, you can drag it. And if you know it ahead of time, you can send it well enough ahead of time, you do not have to move it too much. Just enough, and the next time it comes close by, it will miss the Earth. That's enough. That's all you want. You want to nudge it. One way is to do it with the gravitational attractor. Another way is that you can have a bomb. Not blowing it up. You're blowing the bomb close by, so it can put out a lot of heat, a lot of energy. That can push it a little bit, but the biggest bang you got out of it, you melted the material, hot, it wants to come out, and it acts like a thruster. It will move the asteroid for you. And then there are other things that somebody came up with that, okay, I don't have to stand up a bomb, I just can put a big mirror there, put the sunlight on it, and as it vaporizes the asteroid very, very slowly, it will move it. Or you can have a kinetic impactor where you actually nudge it by hitting it like you are playing cosmic billiards. So, in conclusion, don't lose sleep over it. Astronomers are keeping an eye on it. And I can assure you that probably for the next 10 years, Let me finish. For the next 10 years, you're not going to hear any catastrophe or anything, but keep an eye for those fireballs because if you see them at night, they are really spectacular. Thank you.
Okay, we only have time for a couple questions. So a couple questions about how we're going to die. Over here in the middle.
No, we don't. Not by asteroid.
Did you talk into the microphone? Oh, sorry. I repeat the question.
So how much ahead of time do I need to know? Probably a couple of years warning. When you discover them, when you discover them, they are fairly close to Earth. If you're in a crosshair on that approach, when you first see it, you cannot do anything. However, the way it works, this has a very elliptical orbit, so the next time it comes around would be at least 2 to 7 years, or maybe a little bit more. So it means that you actually have some time to prepare. Probably not one country or two countries, but it really has to be done as an international cooperation. But you could send up a spacecraft and, for example, do the gravitational tractor. The point is that it's really hard to put something into space, and we don't have strong enough engines to get a really, really high speed, so you need enough time with that slow speed to actually catch up. So I would say you need about 2 to 3 years warning minimum.
Can you use radar or some active technology to track the orbit, or is it all done passively through?
Oh, it's a very good question. Most of the asteroids don't. Okay, we have the Arecibo radar, which is very powerful, but you cannot point it. You can catch whatever comes into its field of view. And then there is Goldstone, which you can point, but not as powerful as Arecibo. So most of the observations you're doing by telescope. But there are some which comes close enough and comes within the view of Arecibo that we do actually track it. And when you do that, you have a much, much more precise measurement. So when you can catch an asteroid by either Arecibo or Goldstone, you can get the distance very precisely. You can figure out the orbit very precisely. So that is a very big help. It's just that, if there's that piece of light up there, even if it's really, really tiny, I can see it. Arecibo needs to send out a radar signal and receive it back, so it restricts how far it can see.
Okay, just time for one more question over here.
Unknown. What certainty do we have that we are? What certainty do we have of our certainty that we're tracking all objects that we possibly?
Well, I looked at the statistics. If you care about something which is 1 kilometer or bigger, we probably discovered about 95% or maybe 97% by now. If you worry about this 100 to 300 range, then we are just starting to scrape, the top of it. We are getting the cream of it. I think at the moment we are about 30%. We discovered 30% of the theoretical value we expect to have out there. And that's quite a bit. We already know 10,000 NEOs, and depending where you cut off the lower limit, whether it's a meteoroid or an asteroid, we expect to probably go up to close to 100,000 or 150,000. Now, some of them will be really small. We just were lucky enough to see because it's close by. But I would say we can be at least, we are 95% sure that we are not getting a civilization killer in the next couple of hundred. The prediction I have seen went to 2,800, so I'd say we are pretty sure. 2,800, yes. Yeah.
Okay, so we're out of time. So let's say thank you very much to Moondancer again.